In this demo, we want to show how to use the methods of the string class. We'll do this in a manner similar to what we did for an earlier demo by creating a small experimental program from scratch. This is something you should feel free to do and experiment with as you learn additional Java classes. Just as a refresher, the string class is a standard part of the Java API, so we always have it available to us in our programs. We can find its API in two places. Excerpts of some of the most common methods you'll find in previous lecture notes and videos, and all of the available methods of the string class are given in its online Java API. Some of the common capabilities we'll go over are: how long is a string? Finding specific characters or patterns in it. Extracting specific characters or patterns from it. Manipulating its case. And creating larger strings from smaller strings using string concatenation. So for starters, let's set up a new Java class called String Sandbox in our working directory by doing File, New, Java, and we'll start this out by creating the outer shell of a class. So we'll do public class string sandbox, open brace, closing brace. Next, inside of it, we'll add the required main method. So public static void main string bracket bracket args, closing parenthesis, closing brace. And I like to start all of my classes in this way by setting up the framework and the nesting of the required class and main method. Notice that even though we have a template, we're not using it. I'm just trying to emphasize the fact that we're experimenting with this class. We don't have to turn this in, so we don't have to worry about a header or anything fancy, but for code that you turn in, of course you have to do those things. Now, to do anything with the string class, we have to start out by creating a string object. So we'll do string str equals I am a brand new string. How about that? Now remember that string is unique in this, in that most objects require you to use the new keyword to set up a string, but string lets you do this shortcut. So now that we've got this string object, let's do some stuff with it. For starters, let's print it out. So let's put a label on this. Say the string is, I'll put a couple tabs on there for a little more readability, and then the name of the string object. So we've got string concatenation going on here. Here's a string, and we're gluing it together using the plus operator, the string concatenation operator. So let's save this. It's going to save it to the correct name. Probably should have saved this a little bit earlier, but I guess we missed that. We'll compile it, run it, and there's the string. So what else might we want to do with this string? Well, how about the length of the string? So system.out.println length is, my spelling's not so good this morning. How do we get the length of the string? Well, string object dot method, in this case it's the length method, and length returns an integer for the length of the string, so this entire expression is nothing more than one integer. So we're just effectively printing out one integer. So let's close that statement and terminate it, and we'll save it, print it. The length of the string is 23. That seems about right. Okay, how about extracting specific characters from this string? For that, we would use the charAt method. So let's pluck out the first and last characters of the string and print them. System.out.println first char is tab tab string concatenation. So str dot charAt, what's the first character of any string? The first index is 0. So we give it an index that we want to pull a character out from, and this entire expression is one character. So we can print that out. And what's the corresponding expression for the last character of the string? Well, one way to do it would be to hard code it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so the last character's at index 22. So we could just hard code that in here as follows and compile it, save it, compile it, run it. First character is an I, last character is a G. That's great, but what if this string changes? This is no longer going to give us the last character of the string if we hard code it like this. And even worse, what if the string is less than 22 characters? What happens then? Now we've got an even worse problem. We've got an exception error, an index out of bounds exception, because we don't have 22 characters here anymore. So this isn't a great way of doing it. So let's generalize this by coming up with an expression for the index of the last character. And remember, we said that the length of the string is simply string.length. If we back off by 1, this is always going to give us the last character of the string, no matter what the string is. So we'll save it, compile it, run it, and now we're getting the last character. No matter what the string is, this will always give us the right result for any length string. Okay, what about manipulating the case of the string? That's a job for the 2 uppercase and 2 lowercase methods. So let's print this string out in uppercase and lowercase. So lowercase str dot to lowercase, and let's do something similar for the uppercase. Get a little smarter by just copying and pasting these lines. Let's do something a little different. Let's say we're shouting this out to uppercase, and I'll put some emphasis on the end of this. Save it, compile it, run it. Lowercase string, uppercase string being shouted out. Okay, so what's next? Well, let's try to find specific characters or patterns within this string. For example, let's assume that these spaces are the delimiters, so let's find the locations of them inside this string. Well, let's start off by doing this. Let's say that we have a char separator character, and we're looking for a space, and we want to find the first couple locations of those spaces. So let's declare a couple of integer variables to hold those results. Let's say position 1, position 2, position 3, and position 4. In other words, position 1, 2, 3, and 4. So to find a pattern within a string, we'd use the index of method. So let's find the first occurrence of a space. P1 equals str dot index of, and give it the pattern we're looking for. We're looking for the separator character, and that'll give us the location of the first space. Like so. Let's try it. Save, compile, run. First space is at 1. True, that's the first space. To find the second space, we can't simply do the same thing repeated. We actually have to start searching one space past the known location of the first space. So what we'll do for the second one is we'll use an overloaded form of index of, and we'll say that the second character, we'll search for it starting at the location P1 plus 1, and so this is where we'll find the second space. Save, compile, and run. And indeed we find it at the fourth space. So we could have done the same thing in this first search by starting our search at 0 to emphasize the point. So continuing on with this, let's go ahead and find the third and fourth spaces, and we'll find the third one by starting our search one past the second one. I'll update these prints accordingly. Notice that one way to efficiently write your programs is to get the first instance of something working and then use copy and paste to your advantage. Just make sure that you copy and paste everything thoroughly and completely from past hard-won experience. Alright, so we'll save that, compile it, run it, and the spaces are located at 1, 4, 6, and 12. Next, let's use the known locations of these spaces to extract a specific pattern from our string. We know where these spaces are. Let's use those to extract this word brand. So let's do this. Let's declare a new string object to hold the result, and this is a job for the substring method. So what we'll do now is we'll say sub str equals str dot substring, and what we need to pass substring is the beginning and ending anchor points. So we know that this is the location of the third space, so we'll start one space past that, and we will extract up to the fourth space. And remember that substring has that little oddity where it actually extracts to one before this second argument, so it's going to extract up to the D, which is what we want. So let's go ahead and print this out as always to know that we've done things correctly. Extracted string is a couple of tabs plus substring. Save, compile, run, and it is in fact brand. Lastly, sometimes when we extract strings from a larger string, we have a need to clean up any leading or trailing spaces, and that's a job for the trim method. So let's go back to our original string, and we'll add artificially 3 extra spaces of padding at the front and back ends of this. So let's declare a variable to hold the trimmed result, and what we will do is we will say trimmed equals our original string dot trim, and what we'll do to convince ourselves we've actually trimmed it is we will print out the trimmed string like so, and we'll print out the length of the trim string and compare it to the length of the original string. So I'm just taking the length of the trimmed string. Again, we'll save it, compile it, run it, and let's see. This is the original string, and you can see that there's some padding at the front. It's of length 38. Here's the trimmed string. We've gotten rid of that initial padding, and we've taken off 6 characters from it. So that's how trimmed works. Now, in conclusion, what we've done here is some free format experimenting in a sandbox Java class. But this represents a good way to get started on your programs. Of course, when you turn in your code, I expect to see things like a header block, indentation, commenting, nicely formatted output, and that kind of thing. But this is a good way to get familiar with a class before actually writing the specifics of the program that I've asked for. But at this point, you should have enough examples on hand to be able to complete your strings program.